reducing a collection. So this is a general operation. Here's the very abstract way of writing it. This is probably not helpful at all in the beginning, but let's look at the second code block. So this is just again a generic example of reducing. We have rf, the reducing function, we have some initial value and a collection x, y, z. So this is actually, if you want to imagine the reducing process, this turns into that call. Okay, as you see, the reducing function takes, well, the initial value in the beginning and the first item. Okay, then it produces a new result, then takes that new result and the next item from the collection. So basically what the reducing function does, you have the result so far and the next item is coming from the collection, and you somehow compute the new result based on the result so far and the next item, and well, that's what the reducing function returns, and that's new result so far will be fed into again into the reducing function. Okay, so this shape turns into this one. Okay, well, of course this is abstract, so it's probably not helpful at all. So let's do an example. Say I have conj. It's a good reducing function because it takes a collection and an item and just puts that into the collection. So what do we get? Well, I get 1, 2, 3, 4, 5 in the vector. Okay, so here's a tip, is that you don't need to imagine the reducing process. If you remove reduce with reductions, it gives you the collection of all the intermediate steps. Okay, this is how the reduce conj works. So you have the initial value here, and then you take the next item and the conj will put 3, so that's the new next item, and then 4 and then 5. So this is basically, I can do the translation, so that will be conj 1 and 2, 3. Okay, so that produces 1, 2, 3, and then the conj now 4. Okay, and then another conj. Okay, so what I did, I took this one and just showed how it looks like, what's the process, how you can imagine it. This is exactly these two. Okay. So again, if you think of the metaphor of collecting pebbles in a bucket, well, it's 1, 2, this vector is the bucket, initially has 2 pebbles, and we put 3 more pebbles into the bucket. There is another example, reduced by max. Okay, let's just have some random. Okay, and it just produces number 8. How does this work? Well, again, if you want to see what happens here, then you can ask for reductions. Okay, we take the first one, that's the maximum so far. Then we take 2, oh, that's bigger, we keep it. Then we take 3, oh, that's bigger, we keep it. Then we have 6, oh, It's the biggest so far, so let's keep it. Then we receive 2, and we keep 6 because 1, 2 is smaller than that. So then we got up to 8 when 8 is bigger than 6, and after that we just keep that. And well, reduce just returns the very last here. Okay, so max is also a good reducing function. It can take, well, any number of arguments and can take 2. So if it can take 2 arguments, and it makes sense that the first one is the result so far and the second one is the next item, yeah, that's a good reducing function. And well, okay, now this is something quite confusing in the beginning, although it's not a big deal. So plus is a good reducing function as well. This is sort of, yeah, looks similar. It's like what's going on. Well, of course, reduce is way more general. And probably if we checked, we would find that, well, plus is actually doing reduction anyway in the middle. Okay, so so plus is also a good reducing function, and in this particular case, well, there is not much difference between these two, but you know, apply has a very special restricted use. So now let's have an example where we actually want to have to write a reducing function. Okay, and it's what we want to do is to re-implement count. Okay, imagine we don't have it, and we have to write it. And of course this will take a collection, any collection. Okay, and what do we do here? Well, basically, you know, when we go through the collection, for each element we want to add 1 to an initial number 0. Okay, so it's like, well, it's gonna be a reduction. So what is the reducing function? Well, okay, I don't know that yet, but we will start with 0 and we will go through the collection. Okay, so the reducing function, what's the result so far? That's the number of elements. Okay, or it's like, yeah. And that's well, that's the initial value. Initially n will be bound to 0. And what's the second? So the next item, well, that's coming from collection. So does it really matter? Well, not really. We are not processing the element. We just sort of record the fact that we have one. So this is convention. When you have to name a argument and you are not planning to use it, you just use underscore. But that's just a convention. And what do we do if we have a next item? Well, we increment n. Let's see, does it work with the empty collection? Yes, it does work. As you see, it works exactly like the original count. Okay, so these are examples of reuse. So it's like, well, you see, there are many examples, and it's like you wouldn't think it's like, oh, counting is actually reducing a collection, but yes, it is. It's like you have a collection and you reduce it down to a single number, the number of elements. So now let's go back to the initial abstract definition. So reuse starts with an initial value and go through a collection one by one, and for each element, each item in the collection, it calls the reducing function. The reducing function has two arguments. It takes the result so far, which is at the very beginning is the initial value, and then produces a new result so far in the process based on the result up to that point and the next item coming from the collection. So you can think of whenever you have reduce to turn into this. Well, of course, if you have many elements in the collection, you can only do it in your head. But this is a good way to visualize, at least internally, the process of reducing. And you can sort of, well, in a way, debug. If something goes wrong, you want to see what reducing is doing, you can use the function reductions, and that will, it basically shows you each result so far and the final result as well.